Hello there, welcome back. So we are going to delve into vectors fully. Now, before I go into calculation under vectors, it is imperative to note that vectors are represented usually with an arrow sign. Okay, they are represented with arrows. They are pointing in a particular direction. Just to note that, and then the length of for instance, if I should draw a force vector, say I draw a 3 Newton force, okay, the magnitude of the length rather is proportional to the magnitude, okay. So I would naturally not draw a 3 Newton force longer than I would draw a 4 Newton force, okay. This basically tells you about the magnitude, the line, and then the arrow pointing tells you about the direction. So if you are to find the resultant vector, uh, resultant is basically that force vector that will replace the given vector system. Okay, is the vector that when these two vectors are combined together gives you the result. Okay, it can replace this whole thing. All right. So if both of them are traveling in the same direction, for instance, I can now say that the resultant vector will be 3 Newton plus 4 Newton, and that gives me 7 Newton. Pretty simple, but we'll look at more complex ones by the time we go ahead. And let's say that this is also facing the other direction. So right here now, since we have a 4 Newton force going this way and a 3 Newton force going this way, our resultant is definitely going to be 1 Newton, or 1 Newton facing what? This direction. Now, let's move quickly away from that and then look at more complex calculation as we go in bit by bit. Now, if we have a 4 Newton force and a 3 Newton force in this direction, what will be the resultant? Whenever vectors are meeting at right angles, their resultant is usually drawn from the common point. When they are meeting at right angles, alright, we can find the resultant using Pythagoras theorem. It's pretty basic. We can find the resultant using Pythagoras theorem. So let's say this is vector A and this is vector B. Normally we draw the resultant as the line that comes out from the common point, and then we can replace this first vector and move it this way. Okay, can move it this way, so we have our vector 4 Newton still here, okay, and then this 3 Newton force. So here we have a triangle, and then we can calculate and say that our vector C will be the magnitude of our vector C will be c square. So just say c square equals to a square plus b square, taking the magnitude. Okay, it tells you that you are taking the magnitude of the vector, you are not considering the direction now. So that tells you that c, the magnitude of c, will be the square root of a square plus b square. So the square root of a square, that gives us 4 square, which is 16, plus b square, that gives us 3 square, which is 9. We add both together, we have that this becomes the square root of 25, and the square root of 25 is 5. Now 5 Newton is the magnitude of this direction. Now, how do you get the direction of the vector? Now, your resultant vector is always on your horizontal line. Your resultant vector should not be taken like this. No. Your resultant vector should always be, your resultant should always be on your horizontal. Okay. So to get the direction, theta will take, you can take any one, you can take any trigonometric function, any one, okay? But let's take, what do we have here? Opposite, and this is what? Adjacent. Let's take tan theta will be equals to opposite, which is 4/3. Okay, so theta will be equals to the tan inverse of 4/3, and then you get your theta. I think for this we should be having something like 53.13 degree as theta. But if you are to represent this, for instance, you want to report your resultant, when you have something like this is north and this is east. Your resultant is gotten from this common point here, and you have 53.13 degree. You don't take the bearing east to north, you take your bearing north to east. Okay, so the answer here, if I were to say my resultant is equal to, the magnitude is 5 Newton, the resultant will not be east 53.1 degree north. It's wrong. It will not be north 53.1 degree east. This is also wrong. So what you do, since this is 90 degree, you subtract 90 minus 53.13, and then you should get about 36.19 thereabout. So your resultant will be 5 Newton north 36.1 degree east. So this will be the magnitude of your resultant. Now, these are pretty simple. We are going to look at the parallelograms law in our next lesson. Thank you.